Hello friends, today we will be discussing about principle of electrophoresis. Electrophoresis, simply we can say, it's an electrokinetic phenomena in which there is movement of ions in fluid under the influence of electric field. It's the simple definition that you can remember. Now, what this electrokinetic phenomena means. Electrokinetic phenomena occurs in heterogeneous fluids. You know here electro that accounts for the electric field in electrophoresis, and kinetic, that's the kinetic energy of the ions that are moving in the electrophoretic setup. This the kinetic energy, it is due to the motion of these ions. So this is all about what electrokinetic phenomena is. Simple explanation of electrokinetic phenomena. Now guys, getting to the point, the principle of electrophoresis is based on Coulomb's law, or we can say Coulomb's force. You all may be knowing what Coulomb's law says or what Coulomb's force is. If you are not knowing what Coulomb's force is, watch my video on Coulomb's law and you will get it. In Coulomb's law, we experience with the force. The force experienced by any particle in an electric field is given by Coulomb's law. That's the simple you can remember, or I can say. And in electric field, we encounter with two main forces, and I will be discussing later on what kind of forces are these. The equation of these two forces can be rearranged to get the electrophoretic mobility, and that's the main aim of this derivation, to get the electrophoretic mobility. And from this electrophoretic mobility, we'll get the velocity of the ions in an electrophoresis. And let's get the point, and let's derive this electrophoretic mobility, which will be our main aim from this derivation. We know that electric field is defined as force per unit charge, where E is the electric field in the electrophoresis, F is the force experienced by the ions, and Q is the charge on these ions. To simplify this equation, taking Q on the left hand side, we get F is equal to E into Q. This is the force experienced by the particles in a fluid during electrophoresis, and it's due to electric field. Guys, keep this in mind. This is due to the electric field because there are two forces, and do not overlap these two forces because they are the two different forces that oppose their directions. Another force in electrophoresis is drag force, or we can say frictional force. It's due to the friction of these ions with fluid. It's denoted by Fd, and this drag force, or Fd, is given by F into V, where F is the frictional coefficient and V is the velocity of the ions. Now we are dealing with the two forces. First force, that's force due to the electric field, and another force Fd, that's the drag force, that's due to the friction. Fe and Fd must be zero in electrophoresis for the net movement of the molecule. Otherwise, there will be no movement in the electrophoresis and electrophoresis will be failed. In order to get the electrophoretic mobility, we will simplify these equations. In electrophoresis, there is a net movement of the molecule. That means the force due to electric field equals to the force due to the friction. When putting the values of Fe and Fd, we get Q into E equals F into V. And after simplifying this, we get electrophoretic mobility, which is denoted by mu. Rearranging the equation, we will get the velocity of the ions in the electrophoresis. Like this video if you like it, dislike this video if you dislike it, and please subscribe to my channel so that you may not miss a single video. Thanks, have a nice day.